erase this and work one example. I usually do this right in the middle, but I think it'll help. I should have kick-started with using this example already. It's in the notes that Andrew was asking me questions about it, and you're asking me questions. That means that it's time for me to understand it. Suppose, and the thing I'm doing here, integration by parts can be memorized as a formula. It can be just memorized as a formula. You see this kind of problem, you apply this formula to it. But as everybody who's had me for a semester knows, I'd like you to understand a little bit of the background of where these things come from. And integration by parts isn't magic. It's the product rule. Integration by parts and the product rule are the same thing. So if I want to find the antiderivative of this, first I could just try guessing things. I could try U substitution, U equals Ln of x. I could try algebra. Can I simplify it? Okay, fast forwarding time, I now spend an hour trying both those. I've given up because they ain't going to work. And I say, well, let me think for a second. If I had x squared ln of x, and I took the derivative of this, what would I get? I'd get 2x times this, plus x squared times 1 over x. Correct? I think my derivative right? Do I remember my product rule? Derivative of the first, 2x times the second, plus the first times the derivative of the second. Well, that was a lucky stroke of genius. I thought to take the derivative of this because the derivative of this gives me back an x ln of x, which is what I'm trying to find the antiderivative of. And what's over here and what's over here are both easy to integrate. Why do I say that? Well, let me write down the integral. X squared ln of x prime dx equals integral 2x ln of x dx, which is basically the integral I want times 2, plus the integral of x squared over x is x dx. Well, this I can anti-differentiate, right? The antiderivative of that is 1/2, is 1/2 x squared plus some constant, plus, I'll factor the 2 out of that integral. Well now, if you take the derivative of something, and then you take the antiderivative, where are you?
Back
where you started. Yeah. You go around in circles, right? So this is easy to integrate because it is just this. And I am going to put a little constant in there. Because if you take the derivative of something, here's x cubed, take the derivative of 3x squared, and take the antiderivative, well, there's lots of them, right? So, you take the derivative, you take the antiderivative. Now, wait a minute. The only integral I have left is the integral I wanted. So if I just solve for it, I have the solution to the problem I started with. So I'm going to solve for this, like college algebra, and solve for this. Move this over to the other side. X squared ln of x plus c minus 1/2 x squared minus k is twice the integral of x ln of x dx. Divide through by 2, or multiply by 1/2. 1/2 x squared ln of x plus 1/2 of c minus 1/4 of x squared minus 1/2 of k is the integral I was trying to solve for. So really I use the product rule to find an integral. Now, I'll rewrite it as ln of x dx. And I'll rewrite it as just 1/2 x squared ln of x, that, minus the 1/4 x squared, and then I'll just say, look, this is just some real number. It's some constant. I don't even know what it is. This is some constant. I don't even know what it is. So I'll call that whole thing again, some constant, right? It doesn't matter. If you take the derivative of this mess, you'll get x ln of x. And you can check. Take the derivative of this side. That's what you'll get. So the next few problems in the homework, for people that already know there's this split trick, we'll write a little rule up there. And for those of you who don't, you can do a couple of them this way. I'll write the rule up at some point. But if you understand this process, then not only will you understand the rule, but if you forget the rule, you'll be able to drive it. Because it's actually easier to drive the rule than it is to do process. Any questions or stuff? Okay, that's exactly what Scorpio did back there. We'll get somebody to take a picture, upload it on the page, and you can follow this one through, then you should be able to follow his through and do it the same way. And Chris is going to show you another one, I think, next. And since he did it the same way, I'll let you go first, Chris, and show 220.3. I think you did it the exact same way as what I just did, right? So we can see how that works.